Hello, everyone, and welcome to Kilowatt, a podcast about electric vehicles, renewable energy, autonomous driving, and much, much more. My name is Bodie, and I am your host. And on today's episode, we are going to sit down, or I did sit down, I guess. I sat down with John Harris, the CEO of Harbinger. And what Harbinger does is they build these electric vehicle chassis, or, you might even be able to call it a platform, and they build the chassis with the battery packs and all that stuff, and then they ship it to a third party company, and the third party company builds the box. And these are mostly for delivery vans, but Thor Industries actually built a motorhome, and you'll hear John reference that in the podcast. Anyway, this was a really fascinating discussion. I thoroughly enjoyed it. Um, I did not know that Harbinger only built the chassis. So you'll hear me be a little surprised in the interview when I when I finally realized that. Also, another cool thing is we kind of talk a little bit about fire trucks in there. This was a fun interview for me. I got to express my hatred for A pillars and why I hate our new stock fire truck. It was a good interview. So I'm going to pause for a commercial break. If you're not a Patreon supporter, you can go to patreon.com/kilowatt, or you can look for Acast in the show notes, and you won't hear a commercial break, but I'm going to pause for a commercial break, and then we'll welcome John to the show. John, welcome to the show.
Thanks. Great to be here.
All right. So, John, we're going to be talking a little bit about Harbinger Motors today. And if you could, we're going to start with, if you don't mind, I'd like to start with a brief description of what Harbinger Motors is, and then I've done a little digging on you, and you have a very unique background, I think. And I'd like to just kind of jump into your background, and then we can go back to Harbinger, if that's okay.
Sure.
Okay. So if you want to give us a brief overview of what Harbinger Motors is.
Well, Harbinger is a new vehicle manufacturer focused on electrifying the medium duty vehicle segment. We think that that is the part of the market where electrification is the most interesting. And it's also a part of the market where there's been almost no changes to the vehicles in decades. So there's a great opportunity here to build vehicles that are not only cleaner, they're just better vehicles in every way.
And then what would the medium duty market, how would you define that?
So the DOT defines medium duty as vehicles in weight classes 3 through 6, which is 10,001 pounds to 26,000 pounds gross vehicle weight rating. We've clipped the bottom of that off a little bit. So our vehicles actually start in class 4 and go up to class 6. So 26,000 pounds at the top end, a little heavier at the bottom end because we didn't want to compete with unibody sprinter type vans.
Okay, so these would be like you're looking at delivery vans or some sort of utility or type vans.
Correct. So primarily involved in the delivery of something. Sometimes that's the really obvious things like parcels, but a lot of times it's a B2B service. So it could be maintenance and repair of vending machines. It could be bakery service, commercial garment service, utility repair. But you're always trying to get people or goods out to something pretty local that needs attention.
Okay, so we've got an overview of Harbinger. Let's get an overview of John. You've had an interesting career. You've spanned aerospace, entertainment, EVs. Um, I was wondering if you could just give us a brief overview of the aerospace part of this, because what I found interesting is you worked for Boeing, you worked for Disney, you worked for Faraday Future, and I won't get too much on Faraday Future because I'm sure there's intellectual property stuff in that, and XOS trucks. So, can you just start with Boeing and kind of what you learned when you were an engineer at Boeing?
Well, I've really worked at kind of all points of the cost versus quantity curve. So I started my career at Boeing as a structures and mechanisms engineer, and I was working at the really extreme end of cost versus quantity. So units that were hundreds of millions of dollars a piece that we were building at quantities of less than 5 per program. So that's when we look at any manufacturing activity, there's a trade-off of what do we spend on tooling and what do we spend on basically production means that we can amortize versus what we spend on making individual parts using processes like CNC machining, as well as what we spend on the engineering to optimize the product. So at Boeing, I was out at that end of, we can spend infinite money building the product, but no money investing in cost down and capacity because we're only building, one unit or two units or three units. So we don't get to amortize any of that investment. Uh, from Boeing, I went to Disney, which was at the opposite end. And when I was at Disney, I was working in toy design at consumer products. So from individual units at hundreds of millions of dollars down to millions of units at individual dollars each.
That is nuts. That is nuts. I would imagine that that perspective could really bring something to the automotive industry. One of the things, you know, Elon and Tesla's in the news, but one of the things that people really like about their Teslas is it brings a little bit of whimsy. There's some creativity there. Were you able to bring any of that to Faraday Future or XOS trucks?
But what I really learned is that at any of those extreme edge cases, it's pretty unpleasant. It's either at Boeing, it's unpleasant because they don't really have enough engineering money to make the product great anymore. The engineering is so expensive relative to the product cost that they have to really um, keep people kind of held back from taking the engineering to the point where they'd want to. In almost everything you can probably look at something at Boeing today and say like, this is good, but why didn't they make it 10% better? Why wasn't this part, chamfered a little differently? Or why wasn't there more material taken out of here to save weight? And that level of sort of polishing in a product, like you expect with Apple, right, where every little edge has a purpose, um, it's expensive from on the engineering side. And so you really struggle to amortize those engineering dollars if you're not going to produce them in large enough quantities. At Disney building toys, we had sort of the opposite challenge. We could spend a lot on engineering because we were building something that we were anticipating we would build them in hundreds of thousands or millions of units. And so, you know, wanting like just the right little detail on the toy was fine, but that market has so much markup, stacked margins from the manufacturer, multiple tiers of injection molding and painting and packaging. There's some distributor, then there's a retailer, all of that is supported by licensing going back to Disney. You're sort of stacking markup on markup on markup, and you're doing so in a market that's super competitive, right? Toys are a market where there's a lot of competing options. So we were at the point where we'd say like, we've engineered this feature, it's great, but we're going to cut it because we want to save 15 cents on the product because that 15 cents, might stack up to become $5 on the shelf at Target. So in both of those cases, you're forced as an engineer to sacrifice elements of the product because you don't have those two pieces balanced. You don't have the ability to spend the amount of money you want on both the engineering and the product. So I've found that working in fields where you're selling something that's durable, something that costs, let's say, tens to hundreds of thousands of dollars per unit is where you get the best balance on those things. So that's a good way of describing the automotive industry, right? Things in automotive cost tens to, at rare cases, hundreds of thousands of dollars. But that also describes where Anduril operates for a lot of its portfolio. They're building things in real quantity where they can make a difference, and they're building them, trying to avoid getting into the sorts of bespoke defense platforms that cost tens of millions of dollars each, where you run back into not really being able to amortize the tooling and the engineering to make that trade off.
So, what were some of the biggest takeaways? Because you went from one extreme to another with Disney and Boeing, and then you moved into the automotive industry, and then eventually to Harbinger Motors, the company that you founded. What were some of those takeaways that we were like, I definitely want to make sure that we avoid this, and I definitely want to make sure that we include this.
Um, I think learning that leveraging the cost savings opportunities of investing in fixed tooling. That's something that I saw at Disney. When I was at Boeing, we didn't get to have die-cast parts or injection molded parts because at quantity 5 units, that doesn't make any sense. So at Harbinger, I would say we have tooled up the product earlier in the quantity curve than most people. We've tried to stay more narrowly focused to support that. But if you look at the battery packs we build here today, for example, it's a fully off-tool battery pack. It's a tooled high-pressure die-cast enclosure. It's a tooled module. Everything in there is either injection molded, stamped, or high-pressure die-cast, plus the cells, of course. And that's a very different approach than most people take. Usually they end up with some tooled items, but there's still a lot of machined parts floating around. There might be some vacuum brazed assemblies. There might be some more, um, just sort of low volume production means utilized. And that's generally because they're not quite sure yet what the balance will be and what they're producing. Most OEMs have just too much production mix, and it holds them back on being able to make those tooling investments. So at Harbinger, we try to say no a lot. A lot of new OEMs are frequently asked to do special projects or to make something a little bit different for this customer that we think is going to be great, and we try very hard not to do that because it just kills our ability to make the right investments to help us compete with people on cost.
Now, that tooling that you were talking about with the battery pack, is that what allows you to do, like, the scalable battery packs?
The scalable battery pack is mostly an architecture choice. So our battery packs are scalable because, I guess our battery capacity per vehicle is scalable because each battery pack is in parallel. So each battery pack is relatively small at 35 kilowatt hours, and you can have 3 of those packs on a vehicle. You can have 10 of those packs on a vehicle. Because the packs are all in parallel, and because they have a self-nominating master, so which pack is going to be in charge sort of figures itself out when the vehicle boots up. That means we can use the same pack in every position. Um, Comparing that, if we had battery packs, let's say in series, like if we had a 200-volt battery pack and an 800-volt vehicle, you always have to have 4 battery packs, right? They always have to stack up to the right voltage. So we knew early on that in this market, customers have very different needs and they're very cost sensitive. So we were willing to spend, a little bit more on the engineering challenge of making a parallel architecture work, as well as a little bit more per battery pack to have each battery have basically full voltage range capability, um, but it delivers us that flexibility in return.
Okay, and I know I'm gonna get emails about this, so can you break that down just a little bit further in so that, mortals can understand, in terms of, why it's important? Like, it makes sense that if you have an 800-volt system, then you gotta match that. Why is it important for your scalable battery packs? What makes it different in the platform, I guess?
Well,
I'm
yeah,
not an
like
electrical engineer.
let's think about it if we had like a battery pack with a bunch of double A's in it, right? If we just line all the double A's up end to end, positive to negative to positive to negative, you put all those in a row and you get a certain amount of voltage, 1.5 volts times the number of battery cells. And then if we say, oops, we wish we had more capacity than this amount of batteries gives us, we need 50% more battery cells. We sort of blow up all the engineering because now the voltage range is different. So we need different power electronics, we need different chargers, we need a different motor, we need different insulation ratings on all the cables. Like we just sort of go back to the drawing board if you change the voltage range dramatically. And we don't want to change the voltage range, but we do want to change how much capacity is in the vehicle, right? We do want to change how many battery cells we put in each vehicle because the needs of someone that's doing parcel delivery are very different than the needs of someone that's doing, let's say, utility service or someone doing middle mile or someone building an RV like our customers for. So we know based on how medium duty vehicles are used that we're going to want to put very different amounts of battery cells into each vehicle. And so we just have to sit down ahead of time and say, okay, if we're going to put all these different numbers of cells in the vehicle, how are we going to do that so everything else on the vehicle stays pretty much the same? And we go back to those double A's, lining them up all end to end is a problem. If we just put them all together in parallel and connect all the positives and all the negatives, that's a 1S and then let's say 10P system, 1 cell in series, 10 cells in parallel. If we change the number of cells in parallel, the amount of capacity in the system changes. but the voltage doesn't, which means all the stuff that we connect to those batteries doesn't have to change either. So that's why that modular architecture is really important, so that we can deliver the right amount of battery for each customer while keeping everything else on the vehicle the same.
Is that one of the reasons why you decided to make your own drive units as well? Is that part of that?
No, so we decided to make our own drive units because all the drive units we could buy off the shelf are terrible, to be
Okay.
honest. It's a much simpler answer.
What makes your drive unit special?
So our drive unit has a bunch of architectural differences from what everyone else uses. The biggest one is that it's an integrated drive unit mounted to the chassis. So when you look at a Harbinger drive unit, it's an electric motor, a transmission, and a differential all in one package. Now that should sound familiar if you've seen a Tesla drive unit or a Lucid drive unit. What we're doing is very kind of philosophically similar to what leading companies are doing in the passenger car electrification space. When I say our drive unit is very different than what's in the market, I'm talking about trucks. And in trucks, you don't find anything that looks like this today. Normally, in a medium or a heavy duty truck, you have what's called a live axle. So that's an axle where the whole thing is solid. There's a differential in the center, the pumpkin, and you've got a rotating shaft that sends torque into that differential. The differential rotates the torque by 90 degrees to get it spinning in the axis you want it to spin at, and it provides that torque slip capability between the two wheels. So that axle, by virtue of being a solid axle, it's unsprung, right? That axle is not protected by the suspension. You've got the axle, then the suspension, then the vehicle. So the axle is really punished by the road. Every pothole, every bump and curb strike, they're transferring the full load into that axle because you don't have that suspension in between to cushion it. And then the format of this whole architecture takes up a lot of space, right? You've got the live axle, and then you've got this sort of T shape, right? You've got the prop shaft that comes into it, and that runs to the front of the vehicle where you have the transmission and then the engine. So that's how a normal ICE medium or heavy duty truck is built in the US. And what most people do in electrification is they just look at that and say, well, we've got this rotating shaft that connects to the axle. Why don't we just spin that with an electric motor instead of a diesel motor? And they basically cut the prop shaft and put a big electric motor in. It's really simple, and it's what we would call the faster horses approach to electrification. It ends up with a really big electric motor because you're trying to replicate all the torque output that you get from the regular engine plus transmission. It takes up a lot of space in the vehicle because you've still got a big prop shaft in there, and the whole thing just ends up really heavy. So for us, we basically deleted all of that stuff and said, okay, what's from scratch, kind of first principles, what's the right way we want the axle architecture and drive unit to work in a vehicle? And we said, well, first of all, we don't want a live axle because a live axle carries both bending moment and torque. It's difficult to optimize it for either of those use cases, so it tends to be really heavy. We want some kind of axle that carries bending moment, so it holds the hubs upright, keeps the two wheels like this and not like this. So we want an axle that does that. We'll use a dead axle for that. That means it's an axle that doesn't rotate. And then we need some other way of getting torque from a motor out to the wheels to make them spin. So in the Harbinger drive unit, you've got a really high power density, high speed electric motor. You've got transmission, so a series of rotating gears that dial that torque up. Our transmission has a roughly 10 to 1 gear reduction in it. And then we have a differential. And we want to take all that stuff, put it in its own package, and then mount it to the chassis, not to the axle, so that it's a sprung system and it's protected from road loads by the suspension. Then we've got to connect it out to those wheels. So in our architecture, we have a dead axle, a chassis mounted drive unit, and then articulating half shafts, which connect the drive unit out to the wheels. And the result from that architecture is a system that's not only more durable, it's about 50% lighter than what most people build an electric truck with.
Yeah, I mean, when When you look at EVs, especially bigger EVs, weight is a
Mhm.
big thing for sure. So, and durability is definitely a thing. These vehicles are. I drive a fire truck for a living. That truck gets hammered on pretty hard, and the delivery guys in my neighborhood drive pretty similar to how I drive that fire truck. So I can
Exactly.
imagine that's a big advantage.
I mean, and you think about like how much abuse that vehicle is putting on those axles. Right now, imagine if you took an electric motor and you mounted it directly to the axle. That's the other approach that people are using in the industry. They're saying like, well, I don't have space for this prop shafts and all this other stuff. I'll just take my electric motor and I'll just bolt it onto the axle. That'll be great. It'll be nice and compact. But now you've got something that's as delicate as an electric motor. And every time you hit a pothole, you're shocking that thing at 100 Gs plus. So that's the other direction the industry has taken, which is again very different than our approach.
Yeah, no, that makes sense. Is there anything that I miss that makes the Harbinger platform special? Like, um, it looks like based on the website, the two big things are the scalable battery packs and the electric drive units. But is there anything else on the truck that makes it unique?
I think the other pieces are elements that would be really familiar if it was a passenger car, but being a truck are radically different. So like if you look at the front end, you can see we have an independent front suspension. We use a double wishbone architecture, which can't really describe that as new technology, right? We've seen double wishbone suspensions in race cars for 100 years, I guess. On a truck, typically you'd have a solid front steer axle with leaf springs, and that's one of the reasons why when you drive something the size of a fire truck, it handles like a big truck. You jump in, you drive 5 feet, and you're like, wow, this is clearly not a sedan or a Tahoe. Feels way different. It's it's less responsive. It's less comfortable. It's got way more steering load required. So that choice of front end architecture also is a big change. Um, our approach is it just is gives a much more pleasant experience for the driver.
Yeah, well,
And
and a lot
then
less fatigue for sure.
absolutely, I mean our approach has not been to build the best medium duty electric vehicle. Our approach has been to build the best medium duty vehicle. And it so happens that to do that, we think it should be electric. But building the best medium duty electric vehicle is just not good enough. If we want to change the type of vehicle people use in the industry, if we want to bring in such a big technology shift as moving from combustion to an electric drivetrain, we have to make a vehicle that is better in every way. So that people say, well, whether you like EVs or you don't, whether you think climate change is a problem or it isn't, we need to get past all of that and say this is a way better vehicle to drive. What else matters?
So, going back to the battery pack just for a second here, because I know that somebody's going to eventually ask.
Hmm.
With fleets, it's a little different because a lot of these fleets kind of know the mileage that these folks are going to be driving. Whether like we talked about, their folks that work for utility companies or plumbers or whatever, they roughly know how much they're going to drive in a day.
Hmm.
But your battery packs go from 70 kilowatt hours to 175 kilowatt hours, right?
The least packs we put on any vehicle right now is three. So 105 is the bottom
Okay,
currently.
105.
And then we're building vehicles with six. I would say routinely, but we can go significantly higher than that. But yeah, that's a big range, right? 105 to 210.
What are we looking at in terms of range? If somebody was looking at this for like an RV, somebody wanted to convert one into an RV.
So for the pure electric solution, that gives you a range of about 100 miles at the bottom to a little more than 200 at the top, 225 or so. Still not quite enough for an RV, to be honest. Not enough to really make everyone very comfortable with that being an RV. It's enough for most of the trips people make in an RV, but obviously people buy an RV because they want the freedom to really take that anywhere. And so we've got to really support those edge case uses. So that's why in September we showed our hybrid platform. So for customers that know what they're going to do every day with the vehicle, say, well, I'm going to drive this route at 65 miles. A battery is a great solution for that, right? Because you can buy the amount of battery that you need and then amortize it every day by driving that route. when you have a use case where someone says, I think I'm going to go 50 miles today, but like next week I might go 300 miles, it's really difficult to solve with a pure battery electric vehicle because you either buy the amount of battery you think you need and then you can't do the edge case if it pops up, or you buy the amount of battery you need for the edge case and then you probably have too much battery in the car 90% of the time and you're paying for it still. So with a hybrid, we put a more modest amount of battery and then we add a range extender. So you can drive in battery electric mode, or you can turn on that range extender, which is really just a generator, and charge the vehicle while you're driving it. So that helps because the sort of power that you buy up front with a combustion engine, or sorry, the capacity you buy is less expensive because the capacity is only limited by the amount of fuel you can put in it. The fuel tank is obviously less expensive than buying batteries. So we can sell you a 140 kilowatt hour battery in a hybrid plus a combustion range extender with a 50-gallon fuel tank. And then you can get a lot of range when you need it without needing tons of battery expense.
Yeah, this is something that Scout's doing. Dodge, I think, is still planning on doing this. Is this something that you see kind of as a stopgap while we're trying to figure this all out, as being I mean, obviously, it's you see it as being a viable option, but um, this has been a topic in the kilowatt community over the last
Mhm.
couple of weeks. So I'd love to get your thoughts on those generators as range extenders because they're want to be clear they're not internal combustion motors like you would have on a car. These are purely to charge up the battery, not to power the vehicle.
Right. So that's what makes it a series hybrid versus a parallel hybrid. Um, the Toyota products are all parallel hybrids, and you've got basically both. You've got an electric vehicle and you've got a combustion vehicle with some kind of power split to share the power. Um, Usually that gives a really unpleasant user experience because then you don't have enough power from the electric side, so you have to wait for the combustion engine to kick in. That's why trying to pass someone in a Prius going uphill is usually going to be unpleasant. In a series hybrid, like you said, it's an electric vehicle plus a generator. The generator is just there to charge the vehicle. So in passenger cars, I think this is probably the better solution for a lot of people. You know, with a with an electric vehicle for as a sorry with an electric passenger car, the big challenge is that people don't really want to buy the thing they need every day. They want to buy the thing they're going to use once a year. Most people only drive 20 miles a day, and yet for years people tried to sell electric vehicles with 100 to 150-mile range. And you can say, well, that's plenty of range for me to use all week. And those vehicles sold poorly, right? No one really wanted to buy these vehicles with an 80 to 100, 125-mile range because they wanted that flexibility to say, well, I'm going to go on a road trip to Tahoe this weekend. Where's my 300 miles of range when I need it? Even though it's only once a year. And that's really painful because we're back to buying way more battery than you need just to use it once in a while. So for that consumer behavior, I think a combustion vehicle makes a ton of sense. And if you think about the emissions impact that vehicle has, it's I think actually a little better, right? Because batteries do have a cost, real emissions cost to build them. There's only so much material in the world. We don't really want to use the cobalt and nickel because it comes from areas with a lot of conflict. There's lots of reasons to say let's put the smallest amount of battery in the vehicle we can. And so if you have a vehicle with, let's say, 75 miles of electric range and 400 miles of hybrid range with a combustion engine, you're probably just going to run it as an electric vehicle 99 days out of 100, right? Because that 75 miles, you're just going to use the EV. It's going to charge up again overnight, and you're going to have an EV again the next day. But every once in a while, when you need it, you've got that combustion engine. So now we've defended the customer flexibility there for an edge case usage, and we've avoided mining and producing and selling more battery pack than we really needed. So for that situation, I don't think it's a stopgap. I think it's a great solution. For trucks, for our core product, um, I think there are customers who will end up using hybrids from us as a stopgap because they can't get enough charging capacity fast enough, or they still have enough variation in routes that they say, I think I want to use this one most of the time, but I'm going to use it on a different route like twice a week. So for those really well scheduled use cases, battery's definitely the better solution. And for cases where we just can't afford, as a customer, to buy enough battery up front, then the hybrid helps get us there as battery technology evolves. And then
And
back
it
to that, go ahead.
No, no, sorry. Finish your thought.
Was it back to that RV scenario? I think it's just a way better solution for that. Because for an RV, you kind of want a combustion engine anyway, right? Most RVs have a generator. So with our vehicles, with our hybrid platform on an RV, we get to eliminate the generator. So if the customer wants to charge up the battery, if they're gonna be camping 2 weeks away from shore power, they can just kick on that range extender at the campground and charge the vehicle up to keep using that battery to run, their lights and TV and all the stuff they've got in a modern RV.
Yeah, and it's way more efficient. We don't lose quite as much heat,
Exactly.
all that stuff, or the
Right.
energy in the form of heat like you do on a regular internal combustion engine. But this kind of rolls into my next question. So
Mhm.
you did great, John. What are some of the pain points that you're trying to solve? Obviously, we've talked about some of these pain points, but what are some of the pain points that Harbinger is looking to solve with this truck?
Well, the number one pain point we're trying to solve is electric vehicles that are not priced correctly. When we look at a medium duty use case at most of these delivery fleets, um, these companies aren't Apple. They're not like wildly profitable with huge margins to absorb new technology costs. They they tend to be in very competitive markets, right? The amount of money that we want to pay to have packages delivered to our house is $0. So think of the pressure that that puts on these operators. So, I think a lot of people would like to see the medium duty vehicles in their neighborhoods and in their daily lives be electric. They want them to be quieter, they want them to be cleaner, but they're not willing to pay more for it, right? If we said like, hey, all your Amazon and or packages or all the packages from UPS came to your house, but you got to pay an extra dollar for every package. No one's going to go for that. So our challenge is we have to figure out how to get electric vehicles into the hands of these fleets at basically zero extra cost so that they can have the benefits of electrification and we can reduce emissions without asking people to do something financially that we just know they're not going to do. So our investment in Harbinger internally in building tons of IP and building the capacity in being vertically integrated from day one is all in service of that goal to sell electric vehicles at the same price as combustion vehicles.
And what I mean, I guess I don't know what it costs for one of these vehicles. If it's an internal combustion engine, what are we looking at?
So a typical UPS truck, the chassis, which comes from someone like us, and the body, which comes from a truck upfitter, typically costs about $100,000.
Okay. And then so you're just providing the chassis, you don't provide
Correct.
the okay, okay,
So we only build chassis. We do that because the bodies are very, very customized to each user to an extent that isn't really possible in a really an automotive company with an automotive manufacturing capacity. And you could go to those customers and say, well, hey, we're only building these three. You know, all your customization is wrong. You have to use one of these. That wouldn't get us very far.
sure.
Or we can just adopt the existing industry solution to that, where you have people who build chassis and people who build bodies, and the two go together to meet those customer needs.
Yeah, that's a very common thing in the fire service. Like Spartan
Right.
builds chassis. They build their own fire trucks too, but mostly they build chassis.
Hmm.
So that's not that surprising, especially when you look at how custom. We recently bought a stock truck. We didn't customize it,
Hmm.
and then now we're spending God knows how much more money uh, to have it customized, and it's not even in service yet. It's like we're looking at a year out
Just to
since
have
we've
the
had it.
concept of a stock truck is rare, right? That must have been an EV1 or maybe a Crimson to have a stock truck.
It was no, it wasn't a new. It was actually a Pierce, and it was a chief
Oh,
who lasted about 6 months with our department and made some bad decisions. So now we're stuck with him. But yeah, it's crazy. In one way, practically, you think, oh well. a fire truck is a fire truck is a fire truck, right? And then you get this stock truck and it doesn't have 90% of the things that you need on it. It doesn't have very much space in it. It's just it's designed to meet some departments' needs,
Right.
but not ours.
No, I'm unusually probably at the very top end of understanding just how insanely customized those are because my dad sells fire trucks.
Oh yeah, for
My
who?
family's had a business for a long time that sells fire trucks and does service.
Oh, that's awesome. Which trucks? Which vendor does he work with?
Marion
Okay.
for the last I don't know 10 years or so.
Yeah, that's crazy. That's crazy. Um, so that kind of leads us to fleets. If you're building the platform, I would imagine you're building the software. Fleet operators want to have fleet software or something they can tap into to see
Mhm.
all the data that they might possibly need. Um, do you offer that?
So we don't build custom fleet software, but you're right that we build the software on the vehicle. So what's called the application layer, that's all written internally at Harbinger. We do some lower level software as well, um, and then we do all of the controls. So when you push the pedal, how much pedal translates to how much additional electric current and how much torque out of the drive unit. So all of that sort of mapping, that's done with the software that our team builds here. So that means that we sort of have that data like live on the vehicle, and we can expose that to the customers who want it. So some of our more sophisticated customers have you know, either fully in-house or customized telematics solutions, and we'll share with them what's called the DBC file. So that lets you read the packets on our CAN network and find out what the state of charge is and what the brake pedal position is and what the vehicle's current speed is. All of this data that's moving around on we have 4 CAN networks on our vehicle, but within those CAN networks generally. So it's a lot easier for us to do than a legacy manufacturer because there are our CAN networks. They're running with our headers and our protocol, and so we can share that with customers that need it. And then we can also allow customers to tap in directly to the high voltage system if needed. So if we look at Thor, the RV that Thor has shown publicly built on our platform, the what are called the house loads. So this is all the power being consumed in the RV. That all comes directly from Harbinger's 800-volt power system. So we've got a big high voltage distribution box that we built here, and Thor plugs into that and gets to draw 800-volt DC power into Thor's power electronics to power the house, and that avoids them having to have another battery bank. And that's the more traditional approach. On an RV, you normally have some uh, big bank of 12-volt batteries separate from the vehicle's primary 12-volt battery, just to support all those house loads. So by allowing the customers to interface more directly with the core vehicle systems, we make the vehicle more efficient. We reduce duplication that would otherwise creep in there.
And then, so, so it sounds like it's kind of more of an individual thing. And then obviously the people that you're handing this to build the box, and then they're selling it on to another customer, they can kind of tailor it the way that they want, or at least tap into that information and provide that data in a way that makes sense for their customers. Because obviously, your RV customer isn't going to want the same as your delivery driver customer or your delivery service customer. Um,
That's right.
okay. What about infrastructure? Are you helping with when we're looking at fleets or just an individual that's maybe you just got a plumber out there who's wanting to get one of these?
hmm
What about charging infrastructure, that kind of thing? Places a depot for charging solutions at the lot. Does Harbinger do any of that?
So we'll generally connect customers to partners of ours to help them solve that problem, but we're not usually the ones solving it for them. And that really just comes down to staying focused on the part that we're good at, where we actually bring value. And
Okay.
we don't have any IP in um, fixed charging. Like there's companies that are working on that are doing great things, but we prefer not to dabble in a segment like that unless we're really bringing something to the table.
No, and I'm surprised that you're just doing the chassis, but I love that you're just doing the chassis because in the world of like, it just adds cost and complication, and especially when you're, how long has Harbinger been around?
A little less than 4 years.
What was that? I'm sorry?
A little less than 4 years.
Yeah, so when you're just starting out, that adds a tremendous amount of cost. It's great that you're
Mhm.
able to build the chassis and then hand that off, like I said before, so that somebody can get it, a vehicle the way they want it designed. I think that's great.
Right.
Where do you think, Harbinger where would you like Harbinger to be in the next, like, 5 years?
Well, right now, we're building strip chassis, and so that's the part of the vehicle that has the really core electrification content. Right. So to get here, we've had to build an electric drive unit and battery system and software and suspension systems and all of these pretty hard engineering challenges. And that's great, but a strip chassis only lets us address a part of the market. There are a lot of medium duty vehicles on the road that are not step vans and RVs. So now that we're sort of where we think we should be on the strip chassis, the next big project is we need to build a cab, or we need to work with the right partner for a cab. The exact solution of that is something we're still working on, but the next product that we'll launch will be a cab chassis, and that's an important product because it's a much more broadly useful product. If you start from a strip chassis, you can only sell that, that can only go to an upfitter that's capable of building a cab, and that's a still a pretty big engineering challenge, right? Because you're handling seats and windows and lighting and um, a lot of things that are very sort of regulatory constrained, right? You can't just have a vehicle with like a seat anywhere and flashlight taped to the side. You've got to follow very specific rules around sight lines and driver viewpoint and lights and the angle of those lights so they don't, uh, you know, blind the oncoming drivers, and they have to be bright enough so that you can still see the turn signals. There's all of these rules which are um, some of them are very complicated, but mostly there's just a lot of rules to comply with. So when you look at our second product, a cab chassis, that's helpful because we shift a bunch of that burden back to ourselves, right? When we ship a cab chassis, it'll have a cab, it'll have the headlights and the seats and the mirrors and the window, and so that means we can sell it to people who say, I want to build this special dump truck or stake bed or box truck or service vehicle, whatever that is, and they probably have strong feelings about it, and maybe they've got like a great new approach to building it, but that doesn't mean they want to build a cab. So for Harbinger, the next big step forward is being able to bring that platform for electrification to this much broader segment of customers and upfitters who aren't in a position to take on the complexity of building cabs.
That that's a great can I give you a suggestion as somebody that drives,
Sure.
not a medium duty, like, the A pillar, where they put the A pillar in the mirrors creates this enormous blind spot on the passenger side, and it drives me up the wall. Thankfully, we have, a captain, we have, 2 folks in the back that are always looking out, and then myself, but there is a blind spot, like, it
I
is
know.
sizable. It is a size of a car
Well, it's
blind
bigger and
spot.
bigger every year, right? If you drive
Yeah.
vehicles over the last 30 years, that A pillar has gone from being like this big to this big.
Yeah, no,
So
it's
that
massive.
blind spot just gets bigger and bigger.
And then you add that big old mirror so you can see down the side of your truck and you forget about it. You're
Right.
missing an entire section of road for a period of time. So if you could fix that problem and then license that to, I don't know. I've only got 2.5 years before I retire. So Pierce or some other company, I would appreciate that.
We'll just let it connect right to the side windows, right? No A pillar.
Yeah. I mean, structurally, I don't know, but I think that's
That
a
is the problem, yes.
yeah, yeah. Yeah, well, I won't go into that here, but, yes, that
The
is definitely a
the
bummer.
the GM Futureliner is a great example of a vehicle from a very long time ago that has awesome visibility because they didn't really have crash requirements yet.
Yeah.
So if you Google a GM Futureliner, cab. It's basically that. It's just giant wraparound glass front end. You'd probably be in for a really bad time if you rolled that vehicle over, but there's no A-pillar blind spot.
Oh, yeah. It looks like a train.
Yeah,
Yeah.
it's a really cool vehicle.
Super cool.
So that's the sort of thing, coincidentally, that we can also start to enable with some of the control architectures that we have. So if you notice in the front of that vehicle, driver sits in the middle, so you've got great visibility. That's tough with modern steering systems and the way that people want to build vehicles. So we've made a lot of investments internally in brake-by-wire and steer-by-wire to give us the flexibility to reposition drivers. So you can expect to see, I think, over the next 2 or 3 years, a lot more creative possibilities for how people could build trucks when they get the flexibility to move the driver position around without the same level of effort to do so.
Yeah, this is I think this is a super exciting time to be alive in terms of automotive stuff. Like, I was born in the '70s, those cars are okay. Born, went through the '80s, those cars are okay. The '90s, we started seeing some neatness, and then, within the last 15 years, 10 or 15 years, we really started seeing some cool, innovative cars that look like what we thought the future should be, or at least an approximation of what we thought the
Right.
future would be.
Yeah, I think we're going to see. Yeah, that's sort of an interesting point, right? Because we see way less cool concept cars now. We see less approximations of what the future might be, but we see more of what the future actually is. And that's, I think, mostly been disappointing. So as we get to more advanced technology in vehicles that gives builders more flexibility, maybe we can get back to a little bit more of the future as we hope it will be, and a future that's a little bit more creative and more interesting and less you know thick sausage thickness A pillars.
Yeah. I mean, I love what Tello's doing with their truck. I love what Canoo, RIP Canoo, but I love what Canoo was planning on doing.
Hmm.
There's all these companies out there that have these really unique ideas, and maybe, we won't see anything that Canoo did from Canoo, but maybe somebody will take inspiration on that and build something super cool in the future.
There's a remarkable amount of canoe design language in some of the vehicles we've seen over the last 2 years from certain Korean manufacturers. So I think that influence has been spreading, um, whether they exist or don't anymore.
Yeah. No, I agree with that. I think that's cool. John, where can people find you and Harbinger, and if they want to learn more about what you guys are up to?
So we're based in Southern California. They can take a look at our website at harbingermotors.com, and they can follow us on all their major social channels. Um, those would be the best options.
Excellent. I'll put links in the show notes as well. John, thank you so much for taking time out of your day and being on the show.
No problem. Thanks for having me.
All right. I want to thank John for agreeing to come on the show and being such a good guest. This interview started off nerdy, and I love it. And it just got nerdier and nerdier and more fun for me as a host to do. And hopefully it was fun for you to listen to. John was a really great guest. So John, thank you so much for being such a great guest. Like I said at the beginning of the show, you can go to harbingermotors.com if you want to learn more about what they're doing. But you can also follow them on LinkedIn. They're just Harbinger on LinkedIn. And you can follow them on uh, Instagram. That's that service. That's what it's called. You can follow them on Instagram. It's Harbinger Motors Inc. INC. And I'll put links to those in the show notes. And then you can also follow them on Facebook. And I'll make sure to put all of those links in the show notes. All right, everybody, that is it for me this week. If you want to email me, it's Bodie, Bodie, at 918digital.com. And when I say that's it for me this week, that's it for me this episode, because there's more content coming this week. On Friday's show, we have folks from Lead the Charge. They came on the show last year, so I think you're really going to enjoy that conversation. And yeah, I hope everybody had a great weekend, and I will talk to you on Friday.